Hi all, welcome to the lecture series on wireless networks. In my first lecture, I was discussing about the introduction of WLAN, wireless local area network. In this lecture, I'm going to discuss about the wireless LAN technologies. The technologies involved in wireless LAN are infrared, UHF, ultra high frequency, and spectrum technologies. So here we are going to see in detail about the technologies. The two different basic transmission technologies that can be used to set up a WLAN is number one, infrared light, and number two, radio transmission. So what is infrared light? Infrared light, IR, is an electromagnetic radiation with a wavelength longer than that of a visible light, measured from a nominal edge of a visible red light. It is usually employed in short-range communication, and it uses infrared light emitting diodes. A receiver uses a silicon photodiode to convert the infrared radiation to an electric current. A real-time example which uses infrared light is our remote control, which controls our TV or mobile or a fan or whatever it is. It's a real-time example of utilizing your infrared light. Next again to your radio transmission. Radio is a transmission of signals through free space by modulation of electromagnetic waves with frequencies below those of a visible light. Information is carried by systematically changing some property of the radiated waves. For example, see, you are going to change the characteristics of the carrier signal. Either it could be an amplitude, frequency, or phase. If you're going to change the amplitude, we call it as amplitude modulation. If you're going to change the frequency, you're going to call it as frequency modulation. If you're going to change the phase, you're going to call it as phase modulation. And the real-time example of utilizing this radio transmission is FM channels, walkie-talkies. So the screen shows you the comparison of infrared and radio, a very important unionized topic which is utilized, which is usually asked in unionized questions. So just a short comparison between infrared and radio. So as stated earlier, in infrared it utilizes IR diodes, diffuse light, and multiple reflections. Some of the advantages of infrared include they are simple, cheap, and available in many mobile devices. And here no license is required. Shielding is very simple. Coming to the disadvantages, interference of sunlight and heat sources. Here many things could absorb the infrared easily, and it is of low bandwidth. And the real-time example which I've already stated you is the remote control, all the remote control devices. And coming over to radio, it is going to utilize or it is going to use the license-free ISM band which is operating at 2.4 gigahertz. Advantages is you could transfer the signal for larger areas, it covers a larger areas, it could penetrate through walls, it could penetrate to furnitures, etc. Discussing about the disadvantages, it has a very limited license-free frequency bands, and shielding is difficult, and it is interfered with many signals. An example, it includes the wireless LAN, hyper LAN, and Bluetooth, whatever it is. So going in detail about the IEEE 802.11, your wireless LAN is designated as IEEE 802.11. So it was found for the defining the characteristics of the physical and MAC layer. It works in the license-free ISM band operating at 2.4 gigahertz. Original standard get access rate of 1 and 2 megabits per second. There are many versions of IEEE 802.11, say A, B, G, N, and so on. Your IEEE 802.11b, it has an access rate of 5.5 and 11 megabits per second. So some additional features of wireless LAN include the support of power management to save battery power, handling of hidden nodes, and ability to operate worldwide. Let us discuss some advantages of wireless LAN. See, why are you going for this wireless LAN? It is flexible in nature. Why? Because it could coverage a broad area, it could penetrate through walls, and no restriction is found for this. And planning, see, if you are going for a wired network, imagine you have 4 systems in 4 corners of a room, and if you want to interconnect them, what will you do? The 4 wires will be interconnected, right? It will be going around the floor, and if somebody misses to see the flowing of wires, they might happen to fall down. Right, so what should you should plan in such a way that the wires does not come into our foot. So you want planning for it. Whereas going for this wireless WLAN, you don't want any plan. You can just buy the equipment, just convert connection. That is all. That is over. So communication goes without planning. And robustness. See, due to disasters, if due to certain disaster, a tree might fall down, and if your wire connection is going there, the tree might certainly pull out the wire connection. So loss of signals would happen, right? The communication will be lost over there. But whereas going for here wireless networks, nothing. If tree falls down, it is a loss fully for the tree, not for the signals. Still you get connected over there. In QoS, and talking about the QoS, this provides a very low QoS due to interference signals. The signal gets interfered quickly. So here it having a lower QoS. And going for the cost, you are not going to hire men, you are not going to buy wires, you are not going to give connections, you are not going to pay wages for the pay salary for the men who are going to install the wires. So cost compared to your wired network, it is very low. And here certain advanced security and the safety features you have over here. So these are some advantages of your wireless LAN over the wired networks. Then there are certain main goals to be considered while designing the wireless LAN. So what are the main goals you should consider? Design goals should be considered in designing a wireless LAN. The global operations. Okay, the LAN equipment may be carried out from one country to the another, and this operation should be legal. It should use the unlicensed band for continuous operation. In low power, look, your WLAN operating devices are running out of power. So you should conserve, you should save your powering mode, save power modes. So power management functions are necessary in simplified spontaneous cooperation, and you should be easy to use. The WLANs are made for simple users. They should not require any complex management. Protection of investment. A lot of money has been invested for wired LANs. Thereby, you should take this into account such that it does not consume more amount of money. And safety and security, as I told you already, there are interference problem. You should take measures such that the signals not get interfered and you get a proper quality of service signals. Last is the transparency for the applications. So these are the main design goals to be considered while designing a wireless LAN network. So further, we'll be discussing about IEEE 802.11 system architecture, protocol architecture, physical layer, MAC layer, 802.11b and 11a. Let us get started. So the system architecture. So what is it going to explain? It is nothing but it tells you how your network has been connected, either in a infrared based fashion or an ad hoc fashion. So in my previous lecture, I have already told you what is an infrastructure ad hoc. What is the meaning of ad hoc? If two or three mobiles have been connected together using a Bluetooth, we call it as an ad hoc network. I'm not going to use any access point. All are being connected in wireless medium. Infrastructure is nothing but you have an access point, right? You are going to join any two networks via an access point. That is what is an infrastructure. So here I'm going to explain your IEEE 802.11, which is having an infrastructure based access point. So what are the elements involved in it? We have a distributed system, access point, portal, then your stations, and finally your basic service set, and lastly you have your extended service set. So what exactly is STA, station? Stations are nothing but we ourselves, our mobile, our laptop, the terminal which is going to access the medium. That is called as a station. Terminal which is going to access the medium for communication. Okay, BSS. See, if group of stations are going to use the same radio frequency, we call it as a basic service set. If group of stations utilizing the same frequency, we call that group as a basic service set. See, look here at the diagram, this dark blue region is constituting a basic service set. Then access point. What do you mean by this access point? It's nothing but it's going to integrate one network with the another network. Okay, so access point is going to integrate this network with the other network. Typically you could see all the antennas present over there. Next, portal, bridge to other networks. It is a bridge to other networks. Distributed system, interconnection network to form one logical network. It is an interconnection system to form one logical network. Extended service set. This extended service set is nothing but the whole architecture. See, this network and this network have been connected, so the whole network I call it as an extended service set. And this network will be connected to the other network by means of using an ESSID. It has its own identifier. We call it as an ESSID. the name of the network and is used to separate different networks. Going over to the protocol architecture, the figure shows you an IEEE 802.11 wireless LAN connected to a switched IEEE 802.3 Ethernet via a bridge. So I stated earlier, IEEE 802.11 has the functions between your physical layer and the MAC layer. So we'll be seeing out the responsibilities of physical layer, responsibilities of the MAC layer, and how they are going to function. Your physical layer is divided into two layers. One is PLCP and PMD. Your PLCP is physical layer convergence protocols and PMD is physical medium dependent sublayer. So this PLCP sublayer, it provides a carrier sense signal called clear channel assessment and provides a common physical service access point independent of the transmission technology. And your PMD sublayer, it handles the modulation and encoding and decoding of signals. Our main task of a PHY management include channel tuning and PHY MIB maintenance. Management information base. MIB stands for management information base. What are the tasks of this MAC management? So it is used for association and reassociation of a station to an access point. It controls authentication mechanisms. It is doing power management. It maintains management information base. Coming over for the last one, that is the station management. It is going to interact with both the management systems, both your MAC management and your physical management systems. Moreover, it is responsible for all the higher layer functions. Last, your MAC layer, the functionality of the MAC layer, as its name suggests, it is going to give the medium access. Then it is going to fragment all the user data, and lastly, encryption occurs over here. So that is all for this lecture. Meet you back in another series. Thank you.